Welcome dear learners. We are continuing Unit 1, Chemistry as a Discipline and Scientific Analysis. In the present module, we are discussing reliability of the results in quantitative analysis. In this module, we have to focus the Q-test, the principle and its applications, illustration of Q-test, scatter diagrams, method of least squares, illustration of method of least squares, and problems based on these concepts. First of all, we are discussing the Q-test. The Q-test is a statistical tool used to identify and exclude outliers in small data sets. Suppose you are taking some measurements and the total number of measurements taken is 10. Not all the values are very close to each other, but in certain cases among these 10 measurements, 1 or 2 value may show large deviation from other values relatively. Such values are termed as outliers. So, the Q-test is a statistical tool used to identify and exclude outliers in a given set of measurements. It is particularly useful when analyzing experimental data where an anomalous value might arise due to errors in measurement, equipment malfunction or other inconsistencies. So, the supreme aim of the Q-test is to locate and exclude the outliers in a given set of data. The Q-test is based on the principle of comparing the suspected outliers deviation from its nearest neighbor to the range of the data set. That is, in the Q-test, we have to take a value, a fixed value that is called the suspecting outlier, perform the Q-test, and at last, based on the result of the Q-test, we can take a decision that whether the suspected value is an outlier, it can be ignored or it can be included. Such a decision can be made with the help of the Q-test. We can enter into more details and illustration of the Q-test. The test calculates a Q value for the suspected outlier, which is then compared to a critical Q value from a standard table, that is called the Q value table, at a chosen confidence level. In the Q table, there is confidence level like 90%, 95%, 99%, etc. And based on the number of measurement, there is a fixed critical Q value, and that critical Q value has to be compared with the calculated Q value, and based on that you can take a decision whether the suspected value is an outlier or not. Now, the formula to calculate Q value is given here. Q value can be calculated by using the expression modulus of x suspect minus x nearest divided by r. In this expression, x suspect represents the suspect outlier. What do you mean by the term suspected outlier? You are looking all the values and you take a particular value and you are going to check whether it is an outlier or not. That concerned fixed value is known as the suspected outlier. We are suspecting that value and we are finding out whether it is an outlier or not. That is made possible with the help of the Q-test, and the coming slides will illustrate the procedure of the Q-test. And the x measured, x nearest represents the closest data point to x suspect. So, the value of x suspect and its nearest member has to be considered in determining the Q. So, numerator is x suspect minus x nearest, its modulus. And in the denominator you can see the presence of an r term. the R is known as range of the data set. How you can fix the range of the data set? The range of the data set can be calculated by using the expression range R is equal to x maximum minus x minimum. So, x maximum represents the highest value in the given data set. X minimum represents the minimum value in the data set. So, you have to calculate R also. R is theoretically equal to x maximum minus x minimum. By putting the value of R in the denominator and the numerator is equal to x suspect minus x nearest modulus, you will get the final value of Q. So, Q can be calculated by the expression Q is equal to modulus of x suspect minus x nearest divided by the range capital R. Now, if the calculated Q value, the Q value calculated using the expression exceeds, that is greater than the critical Q value, the critical Q value is obtained from the table, the suspected value is considered as an outlier and can be rejected. Now, we are discussing the steps in the Q test. Suppose you are having a set of data. Based on that data, you wish to perform the Q test. In the first step, you have to sort the data. That means arrange the data set in the ascending order. So, you have to arrange all the given data in the increasing order of their magnitude. The second step is the identification of the suspected outlier. We have to select, we have to fix one value from the sorted list as the outlier. For this, choose the smallest or largest value in the data set as the suspected outlier. That means, in a given data which is arranged in the ascending order, you can take the smallest value or you can take the highest value and fix it as the suspected outlier. After the test, you can take the decision that whether it is an outlier or not. Moving on to the next step, we have to calculate Q. Once the data is arranged in the ascending order and picked up an outlier, that is X suspect, you can proceed to calculate the value of Q. By using this expression, Q is equal to modulus of X suspect minus X measured divided by capital R, that is range. You know the range can be calculated by the expression X maximum minus X minimum. X maximum is the highest value, X minimum is the lowest value in the data set which is arranged in the ascending order. Now, the fourth step is the decision making step. In this step, you can take a decision according to the magnitude of Q calculated and Q critical. If the calculated Q value is greater than critical Q value you will get it from the Q data table. Then if the condition is Q calculated greater than Q critical, reject the suspected outlier, otherwise retain it in the data set. This about various steps that we adopt in the Q test. So, Q test is a test which is used to find out whether a particular value is an outlier or not. Now, Q test critical values or Q critical is obtained from a Q table. A Q table, a sample Q table is shown here. The first column represents the sample size. Sample size means the number of measurement. It is indicated by N. You know about confidence limits. Three type of confidence limits are incorporated in this critical value table. The second column represents 94% confidence level. Next column represents 95 and the final column represents 99% of confidence limit. In most of the chemical analysis, we are fixing the confidence limit as 95%. So, you can take a particular Q value, that is Q critical, from this table by noticing two things. First of all, you have to take number of measurements N, and the second thing to be considered is the confidence interval, confidence limit. The confidence limit is 95, and if the sample size is fixed, you can pick up a corresponding Q value from this table. and that Q value is called Q critical. Now, we can illustrate the Q test with the help of an example, that is, we are going to illustrate the Q test. In order to illustrate a Q test, consider a given data set. The given data set consists of some measurements. These values are 2.3, 2.5, 2.4, 2.6 and final value is 3.1. So, here you are having 5 set of values, and among these 5 set of values, you have to fix an outlier, you have to arrange them in the ascending order, and by fixing that outlier as X suspect, you have to proceed with the Q test, and finally you can take a decision whether the value you selected is a real outlier or not. And now we are proceeding to the Q test, and in this data, let the suspected outlier is 3.1. Why I am putting 3.1 as the suspected outlier? On arranging this in the ascending or descending order, you can see that 3.1 is the highest value. You can select either 3.1, the largest value, or the lowest value as the outlier. So, in this data set, 3.1 is the highest value and it is taken as the suspected outlier, and based on that we are going to perform the Q test. So, sort the data 2.3, 2.4, 2.5, 2.6 and 3.1. It is very well clear that 3.1 is the largest value and that is fixed as X suspect or suspected outlier. Identify the X suspect as 3.1 and we are taking X nearest. What is meant by X nearest? In this data set, 3.1 is selected as the suspected outlier or X suspect. The value which is very close to the suspect outlier is taken as X nearest. So, in this sorted data, 3.1 is the suspected outlier and the value which is very close to 3.1, that is nothing but 2.6. 2.6 is taken as X nearest. So, in the present problem, I sort the data in the ascending order, then find out X suspect and X nearest, keeping the fact that X nearest is the value which is very close to X suspect. In the present problem, 3.1 is X suspect, it is fixed as X suspect since it is the highest value and the nearest value of which is 2.6 and 2.6 is taken as X nearest. So, we have fixed two things from this data set, X suspect and X nearest. Now, we can enter into next part, that is the calculation of the range. I already told you the fact that range can be calculated by taking the difference between highest value and the lowest value. That is, range R is equal to X maximum minus X minimum. You can see that the highest value is 3.1 and the lowest value is 2.3. So, the range of the measurement R is equal to 3.1 minus 2.3, that is equal to 0.8. So, you got the values of the range, X suspect and X nearest. Based on this, you can easily calculate the Q value, and the Q value can be calculated by using the expression Q is equal to modulus of X 3.1 minus 2.6 divided by 0.8, and that is equal to 0.5 divided by 0.8 and that is equal to 0.625. So, it is very well clear that you can calculate the value of Q based on this expression. This expression is previously known to you and using this expression you go to the value of Q. Now, you have to compare the obtained Q value with the Q critical. In order to select the Q critical value, you have to fix two things. First of all, number of measurements. Number of measurements is equal to 5, that is n is equal to 5, and confidence level for this analysis is fixed as 95%. So, by using this data n is equal to 5 and confidence level as 95%, look onto the Q table and you can take a particular Q value, and that Q value is Q critical, and Q critical for the present situation is equal to 0.710. So, now you are having two values, one calculated Q value that is equal to 0.625 and one critical Q value that you got from the Q table as 0.710. So, you are having these two Q values. By comparing these two Q values, you can take the decision that whether the suspected outlier 3.1 is a real outlier or not, and that is the comparison step or the decision step. The decision is, since Q calculated, that is Q calculated 0.625 is less than 0.710, 3.1 is not an outlier and should be retained in the data set. If this order is just opposite, then you can say 3.1 is a real outlier and can be ignored. So, in the present problem, the data 3.1 is not an outlier and can be retained with the set of measurements. Now, reliability of Q-test results. The Q-test is designed for small data sets. Usually n lies in the range of n is equal to 3, that is 3 measurement, and it may vary up to 10 measurement. The Q-test can be reliably identify the outlier when there occur deviation from the rest of data is significant. If there is the presence of some outliers, then only the Q-test is more relevant, and based on that you can find out whether the fixed value, the selected value is an outlier or not. The reliability of the test depend on correct use of the critical Q values from the table. You should keep in mind the fact that there is a standard Q table. The values obtained from the table is known as Q critical. Before selecting the Q critical, you have to select the confidence level, and in many chemical analysis 95% is the confidence level. Based on number of measurements and confidence level, you can fix the correct critical value. The selection of the critical value is very important as far as the Q test results interpretation are concerned. The sample size n, the confidence level choose example 95%, 90%, 99%, etc. Now, we are considering another important aspect of quantitative chemical analysis that is associated with some graphical representation. We are discussing the scatter diagrams. A scatter diagram, which is also known as a scatter plot, is a type of graph curve used to visualize the relationship between two variables. It consists of data points plotted on a two-dimensional Cartesian coordinate system, where each point represents the values of two variables. You know about the plotting of the graph by taking x axis and y axis. Suppose velocity time graph, it is very popular in physics. Velocity can be taken along the y direction, time can be taken along the x direction. You will get a different type of curves. That type of graph can be simply taken as a scatter diagram. We are discussing scatter diagram in more detail. In the graph, if the variables are correlated, suppose there is some relation between these two variables, then the point drops along a curve or line. A scatter diagram or a scatter plot gives an idea of the nature of relationship between two variables selected to plot the graph. Now, various type of scatter diagram are there. This is the illustration. I will show you a graph, a scatter diagram, where there is perfect positive correlation between two variables and perfect negative correlation between two variables. This about the nature of the graph. In the first case, there is strong positive correlation, positive relation, direct relation between two variables plotted along x direction as well as in the y direction. However, in the second graph, you can see that there is negative correlation. If one is ascending, next value will be descending. That is the indication of a strong negative correlation or strong inverse relationship. So, these two curves are the scatter diagrams, which represents perfect positive correlation and perfect negative correlation. There are other types of scatter diagram also. Suppose there is high degree of positive correlation, its opposite there may be high degree of negative correlation. How these situations will reflect in the scatter diagram? It appears like this. These curves, you can see several points, and this indicate high degree of positive correlation, and the opposite part simply represents high degree of negative correlation. There is another type of scatter diagram where low degree of positive correlation and low degree of negative correlation. The scatter diagram appears like this. This is low degree of positive correlation, and the next one represents low degree of negative correlation. And there is one more scatter diagram where there is no correlation between the two variables selected along x axis and as well as the y axis. See, in the first, second and third graphs, third scatter diagrams, there is no correlation between the parameters plotted in the x direction and in the y direction. So, there is no connection between the terms plotted, the variables plotted in these two directions. If so, the scatter diagram may appear like in the first form, in the second form, or in the third form. That all about the various type of scatter diagrams. Now, what are the advantages of scatter diagrams? Scatter diagrams are easy to create. Just to plot some graphs by fixing one variable along the x direction and other variable along the y direction. It is simple way of plotting the graph. So, it is easy to create as well as easy to interpret. It helps to visually detect correlations, patterns, and also used it to find out the presence of outliers. It supports hypothesis generation as well as in hypothesis testing. So, it is very important as well as far as the quantitative research is concerned. It is useful for both the linear and non-linear method of least squares in analytical chemistry. The method of least square is a very important statistical procedure to find out the reliability of the results. In analytical chemistry, the method of least squares is widely used for data analysis, especially when calibrating instruments, determining unknown concentration, and fitting data to mathematical model. It is a statistical approach to find best fitting curve or line to a given set of data points by minimizing the sum of the squares of the differences between observed value and the predicted value. It is widely used in regression analysis, curve fitting, and data modeling. All these procedures are high level analytical procedures, and the high level is far beyond the scope of the present discussion, and we are now simply understanding the basic concept under the concept of principle of least or method of least squares. Illustration of method of least squares. Determine the concentration of an unknown solution from its absorbance using a linear calibration curve from the data given. Calibration data, that is absorbance versus concentration, are given in the tabular form. In the first column, the data given is the concentration, which is expressed in units of milligram per liter, and the second column represents corresponding absorbance. Absorbance is to be taken in the y direction, and concentration has to be taken in the x direction, and we have to illustrate the method of least squares. First of all, set an equation for a straight line. You know, the equation for a straight line is y is equal to mx plus b. Y is anything you plot on the y axis, and x is the parameter you are taking along the x direction. M is the slope and b is the y intercept. And the terms are shown here. This about the situation. In the present problem, I am taking absorbance along the y direction. So, y is equal to absorbance, and in this plot I am taking concentration along x direction. So, x is equal to concentration, As I mentioned earlier, m represents slope. The slope represents the sensitivity of the instruments in the present problem, and b represents the y-intercept. Now, in the moving on to the second step, we have to calculate the slope m and intercept b. For this purpose, we have to use separate formulas to calculate the slope and the y-intercept, and this formula is based on the method of least square. This is the expression for calculating m, and the second one represents the expression for calculating b. So, by using these two formula, which are simply complicated formula, you need not to keep this formula in your mind. We are just going through the basic aspects of the methods of the least square. So, the slope can be calculated by using the expression xi and yi are data, different data values which you plotted along x and y directions, and b represents the slope. So, b represents the y-intercept and m represents the slope. So, you have to calculate m and b based on these expressions. Now, you have to compute intermediate values, and intermediate values can be calculated by using this tabular form, and here there is xi value, yi value. Taking square of xi, you are getting xi square, and you have to finally calculate the product of xi and yi. So, you have to multiply xi with yi, you are getting xi yi. For instance, if xi is equal to 1 and yi is equal to 0.12, if you are multiplying together, you are getting very same 0.12 as xi yi. To take the square of xi, that is xi square, it is equal to 1. Moving on to the second data, if xi is equal to 2 and yi is equal to 0.26, the square of xi, that is 2 square, that is equal to 4. On multiplication 2 with the 0.26, you are getting 0.52, that is xi yi. Similarly, based on the given data set, you have to compute all these values xi square and xi yi. This is to put it in the expression for m as well as b that I mentioned just earlier. Now, you have to put all these values and you have to calculate different data m as well as b accordingly based on the previous equation. Now, calculate m and b using the same formula. You will get m by proper substitution, and the last value of m, which is the slope, that is the sensitivity of the instrument, is equal to 0.129. And b can also be calculated. The formula for b is again shown here. B is calculated as minus 0.007. So, you got to two values, the value of m as well as value of b, and by using this m and b, you can prepare a final calibration line. The equation for the calibration line is again y is equal to mx plus b. Then m and b are you have calculated. By putting that value, you will get a final calibration line for the present problem. So, y is equal to 0.129x minus 0.007, and now determine the concentration of the unknown with the help of this calibration line. Suppose the absorbance of the unknown sample is 0.45. To find the concentration x, then rearrange the equation for the straight line as x is equal to y minus b divided by m. This is simply obtained from the expression y is equal to mx plus b. On rearranging it, you will get x is equal to y minus b by m. Now, in this expression, you know the value of b as well as m, and there is a value of y also. Y is fixed, y is equal to 0.45. So, with the help of this 0.45 y and value of m we calculated and value of b we calculated, you can calculate the concentration x. Substitute these values, we will get x equal to 0.45 minus 0.007 divided by 0.129, and the concentration obtained is 3.54 milligram per liter. Now, interpretation of the result is the last step. The concentration of the unknown sample is approximately 3.54 milligram per liter. Now, this is the summary. The method of least squares provided best fit calibration curve. By using this curve, the unknown samples concentration can be accurately estimated. Now, the problems based on the concept we learned. First of all, consider a data set of titration. The volumes are given in ml. These are the volumes 23.5, 23.6, 23.4, 23.5 and final value 24.2. Perform Q test and find whether the higher value is an outlier or not. Look on this data, you can pick up the higher value and we are going to proceed whether the higher value is an outlier or not. Before entering into the calculation, first of all we have to sort the data in the ascending order, the lowest value being 23.4 and the highest value being 24.2. So, from this data set it is very well clear that the highest value is 24.2, you can fix it as X suspect. So, identify X suspect as 24.2. Then you have to find out X nearest. What is X nearest? X nearest is the value which is close to, very close to X suspect. So, X nearest is 23.6 which is very close to 24.2. So, you fixed X suspect and X nearest. Now, we have to calculate the range. The range can be calculated by using the expression X maximum minus X minimum, that is the difference between highest value and the lowest value. The highest value is 24.2 and the lowest value is the first one, that is 23.4. Take the difference, that is equal to 0.8, and based on this you can compute the Q value. Q value is equal to modulus of 24.2 minus 23.6 divided by 0.8 and the Q value is equal to 0.75. Now, you have to compare this calculated Q value with the critical Q value from the table. For this, fix n is equal to 5 because you took 5 set of measurements, and the confidence interval as usual we fix it as 95%, and you can pick the Q value from the table, Q table, that is available. Similar to a logarithm table, it is available. So, from the Q value you can fix the Q critical. For the present problem, I gave you the critical Q value, that is Q critical value is 0.710. Now, you have to compare Q critical with the Q calculated to take a final decision. Since Q calculated 0.75 is greater than Q critical, the value 24.2 should be considered as an outlier and can be excluded. So, in the given data set, the highest value 24.2 should be avoided because it is an outlier. Now, another MCQ based on the matter we have discussed here. Which of the following statements about a scatter diagram in analytical chemistry is true? These are the options. Scatter diagrams are used to find the calibration curves slope directly. Scatter diagrams show the relationship between two variables. Outlier in scatter diagram always improve linearity. Scatter diagrams cannot identify trends in experimental data. On careful analysis, you can arrive at the final result as option B, that is scatter diagrams show the relationship between two variables. Moving on to another MCQ. During a spectroscopic experiment, the following absorbance values are obtained for a sample. The values are 0.102, 0.108, 0.087. Use the Q test significant level 95% to determine if the value 0.087 is an outlier. Critical Q 95% for n is equal to 3 is given, that is equal to 0.941. Calculate the Q value and predict the outlier behavior of 0.087. And these are the options, and on careful analysis, it is very well clear that you can calculate the value of B based on the procedure for the calculation of the Q value. With the help of Q critical, you can arrive at the result that Q calculated is equal to 0.875 and Q 0.875 is less than the Q critical value, that is 0.941, and hence you can ignore this 0.087 and it is not an outlier. So, your option is answer B, that is 0.875 no. That all about the present discussion. Have a very nice learning experience. Thank you.